Solving systems by graphing. What is a system and how do you solve it by graphing? Well, we have to remember that a line represents all the solutions to an equation. When we draw that line from an equation, we know that all of these points on the line are all solutions, whether they cross at a corner or they cross in the middle. So there could be hundreds of thousands of possible solutions to that particular equation. Now, taking that idea, let's apply it to a system. A system is more than one line. So what we're looking for is where these lines cross, where they all cross together, and that will be considered the common solution. Now, we're going to be working with only 2 lines at a time, but you can have 3, 4, 5, 6 lines. It doesn't matter. We're going to stay with 2-line systems, though. So we're going to look for that common solution where they're both going to cross. Now, what we'll look at first before we get into graphing is we're going to talk about it a little bit from an algebra point of view. So here I have 2 equations, y equals 4x minus 7 and x plus y equals 8. And the question here is 3, 5 a solution? In other words, is it a common solution? Is it a solution to both of these lines? So that's why I know where they crisscross. Now I could graph it and find out if that's true, but I can solve it faster algebraically. We have to remember that the first point is the x and the second point is the y. That will help us when we substitute in. So here in place of the y, so we have y equals 4x minus 7. In the y spot, I will put a 5. And in the x spot, I'll put a 3. And then from there, I'll just use order of operations to simplify both sides. If both sides are exactly the same, then we know that that solution is true, or that it is a solution to that particular equation. Now remember, in order to be a solution to the system, it has to be for both. So let's check the other one. And using order of operations, we see that that is true as well. And because both sides are true, yes, it is a common solution. It is considered a solution to the system. Let's practice this a couple more times. Here again with that 0.12, we're going to take this equation, y equals x plus 1. We'll put 2 equals 1 plus 1. And we know that that works out, that that's true. We'll do it again with the second equation and put in the x spot the number that represents the x, and in the y spot the number that represents the y. And we see that it's true again. And again, once because both sides are true, yes, this is a solution to the system. We're going to try this one more time. I'm going to throw a little more negatives at you because the reality is that we've got to do some negative practice. Okay, that's where we're probably hurting the most, in our integers and using order of operations. So we have 2 times negative 2, which is negative 4. A negative 4 and a negative 1 is negative 5. So yes, so far it's true. Let's find out if it's going to be true for the second one. 3 times negative 2 plus 2 times 1 equals 3. When we use order of operations, we get negative 6 plus 2 equals 3. We know negative 6 plus 2 equals 4. So since it does not work for this second equation, the answer then would be no. It's not a solution to the system. So what does that mean for us? Let's go back to our slide about the system and what it looks like. Remember, we talked about the common solution. So in the first 2 examples, this was where it crossed. It crisscrossed where they both hit. But that third one, it was a solution to one line, but it was not on the other line. It wasn't a solution to the second line. So we want to make sure that it's got to be a solution to both of them in order to work. Let's go back now and talk about setting it up. How would we graph it? We need to remember about y equals mx plus b. This format, which is called the slope intercept format, helps us to put things in the right order. If we remember that m represents slope, we know that slope is a number, and it's also considered rise over run. Both of those things tell you that it is a fraction. That rise over run, that numerator over denominator, it is a number, and that's going to help us determine the slope. The b represents the y-intercept. We know that to be where the graph crosses the y-axis. Let me add a little more to that idea about what the y-intercept is and the slope, because these are the two things that you need if you are in this format in order to graph effectively. So let me add one more little thought to that. The b or the y-intercept is where you're going to begin. The slope is how you're going to move, your rise over run. So if you begin at the y-intercept and move rise and run from there, you should be able to graph pretty quickly. So let's take a look at two examples of how to graph. Here I have x plus y equals 3 and x minus y equals 1. So let's take this first equation here. And we notice it's not in the correct format, because remember, our format has to be y equals mx plus b, where the y is by itself. In this equation here, we see that the y is not by itself. There's an x with it also. So we need to get rid of the x. So we've already learned with the equations that if we don't want something on a certain side, we just add or subtract it. That makes it go away, because x take away x is 0, leaving us just with a y. Now, when we look on the right side, these are not like terms. That means they cannot go together. So they're going to stay separated. And what we're going to do is keep the x in the front spot so that it looks like the format. So there's that negative x. And because this is a positive 3, we're going to write plus 3. Now what we're going to do is we're going to get our information. So when we look at this equation, we're going to get our slope and our y-intercept. We know the slope, which is the number in front of the x. We see a negative sign here. That tells us that our slope is -1. We know that it's a fraction, so we're going to put it over 1. And that our y-intercept is this number out there, which is 3. So now if we take this information and we go to graph it, we know that the slope is 3. Excuse me, the y-intercept is 3. And the slope is a -1 over 1. So we're going to rise -1, which means we're going to go down, and then we're going to go to the right one. Go down 1 to the right one. And what we're going to do is we're going to draw a line. So let me get one here, and let's make it red to match. And we're going to draw a line right through those points. And we're going to extend our line so that it goes long in both directions, because we don't know where the other line is going to cross. So we want to make sure we give ourselves ample room of where it's going to cross. Okay, so now we're going to take the second equation here, which is this one here, and I'm going to work it down here. So we're going to say x minus y equals 1. Kind of keep it separate from this one. Now, we're going to run into the same problem again, where we've got to get that x by itself. So what we're going to do is we're going to subtract an x from both sides. Now, when we do that, the x's go away, but we're left with -y equals -x plus 1. Now, the problem with this is it's not a positive y, it's a negative y. And we have to remember that a negative sign means the opposite of something. And if you're looking for a discussion about that, think about it. What is the opposite of 2? Well, the opposite of 2 is 2. So that's when it's talking about the opposite. So when we look at this and said, hey, what's the opposite of y? We know the opposite of y is y, the opposite of x is x, and the opposite of +1 is -1. So really, if we take the opposite of everything, we can get this. Now, how would we find that algebraically? We could either multiply or divide all the way through by -1, because we know a negative times a negative becomes a positive, and that changes the signs along the way. So however you want to look at it. So what we're going to do is look at this bottom one here, and we're going to get a slope and a y-intercept. Again, there's no number in front of the x, but there's an x there, so we know the slope is 1. But again, rise over run will make 1 over 1, and our y-intercept is at -1. I'm going to use green for this one. So we're going to start at -1. That's where we begin on the y-axis at the y-intercept. And we're going to rise 1 and run 1. And you can see just by our dots, we're going to run into the other line. So let's draw our line to show where we're going. Okay. And we have to remember that our answer is always an ordered pair. So we need to find out, what is this ordered pair? This pair, this location right here, is +2, +1. That's the solution to this system. Now, I know it's a lot of work, and it's considered an estimate because unless it lands right in the corner like that, it's really hard to know what the answer is if you get 2/3 or 1.5. So we're fortunate we're going to be kind of working with ones that work out exactly. So if you get something funny, take a second look at it. So let's try to go this last one just a little bit faster. So y equals 3x minus 2 and 2x plus y equals 3. The first one's already in perfect format, all ready to go for us. Y equals mx plus b. We just need to get information. The slope happens to be 3, and the y-intercept is negative 2. We also need to put that slope when rise over run. So here I go to negative 2, because that's where we're going to begin. And we're going to rise 1, 2, 3, and over 1. 1, 2, 3, and over 1. And we're going to draw a line to go through that. Okay. Now what we want to do is we've got to work on the second equation. We do have to do a little work on this one. So 2x plus y equals 3. We need to get rid of that 2x, so let's subtract 2x from both sides. When we do that, the 2x's go away, leaving us with just y, and then this is negative 2x and a positive 3. Once again, we're going to get some information. We know that the slope is negative 2 and that the y-intercept is 3. Again, our slope needs to be a fraction, which is rise over run. So going back up to our graph, we're going to begin at positive 3 on the y-axis, our y-intercept, and then from there we're going to go down 2 and to the right 1, and you can see right away we're going to run into that line. So we're going to draw our line. And always remember your answer is an ordered pair. So the answer to this problem is 1, 1. Hopefully this basic idea of solving systems by graphing makes sense to you, and through some practice and being able to graph, it's pretty quick and easy. But then again, remember, it is an estimate. It is not the most accurate way to do it, but it does get you a quick answer.